Thank you for joining us today for a webinar on applying HVAC systems to next-generation office buildings. My name is Kevin Miskowitz, Director of Commercial Marketing at Mitsubishi Electric Trane HVAC US. I'm pleased to be joined by Rich Jacklin, Regional Manager of Commercial Products for Wisconsin and the Upper Peninsula of Michigan. A few months ago, Rich mentioned to me that he was developing a concise overview of how to deliver the cost message of VRF systems to building owners. I was intrigued by our conversation and am pleased that Rich is going to share the story with us today. The focus of this webinar is to assist in telling that VRF cost story against the cost of more traditional HVAC systems, such as a VAV RTU design, in a new construction commercial office building project. The hypothetical project we'll be discussing today is a 3-story, 78,000 square foot office building in Wisconsin. This webinar is designed to be delivered to mechanical contractors, who in turn would deliver it to general contractors or owners or developers for a specific project. The presentation could also be given directly to an owner as well. When today's presentation concludes, you will see that VRF systems not only provide superior efficiency, but actually deliver it at a very competitive price when compared to a VAV RTU system. With that, I'll now turn the presentation over to Rich to take us deeper into the facts and figures associated with applying VRF to a 3-story new construction commercial building. Rich?
Thank you, Kevin. All right, reiterating, as Kevin said, a friendly contractor shared his bid for a 78,000 square foot shell office building just outside of Milwaukee. Odds are you've seen something similar. It's a 3-story office with a parking garage underneath. Overall footprint is 150 feet by 175 feet. Tenant improvement will be bid at a later date as tenant leases are secured. So a typical solution would be VAV rooftop units with duct loops for future tenant build-out. Provide enough VAVs for temporary conditioning of the space and the entry, as well as the restroom core work for the landlord portion of the work. A premium solution would be to choose VRF as a viable option. You can provide the outdoor units, branch controllers, and refrigeration piping for the outdoor units, as well as a minimum number of indoor units to provide temporary conditioning of the building until TI build-outs occur. And TI is just my acronym for tenant improvement work. Tenant build-out would be the remaining indoor units, refrigeration piping, ductwork, diffusers, and controls for those indoor units. So the question is, why would you do this? Well, the benefits are you can utilize a world-class, highly efficient HVAC system. We will show you by the end of this presentation that by utilizing the options we present, an owner can actually attain a lower first cost than traditional rooftop unit design. Owners can also attain higher lease rates with a green building option. Owners can gain higher LEED certifications with this system. The systems are 30% more efficient than VAV rooftop systems, and these systems minimize hot and cold spot complaints. So let's talk about a traditional rooftop system. The system dictates other traits about the building that will affect the developer's overall cost. These other costs, as shown in the graphic on this slide, include screening for the rooftop units, the electrical power connections to the rooftop units, structural steel for the rooftop units. These costs will be defined a little later on in the program. The important thing to remember is that these costs are truly additional landlord costs required outside of the HVAC scope of work. So when you slide all those other costs in, the landlord's portion of the budget gets larger. So let's compare what HVAC components will be in the landlord's and tenant scope of work for this analysis. For the base design, landlord work will include the rooftops, the duct loops on each floor, as shown on the following slides, as well as the VAV boxes for control of the entry corridor on the first floor and the restroom core work. For the VRF options, the outdoor units, whether we locate them on the roof or in the parking garage, are included. So we are going to provide 3 options for VRF design for this building. The first option is to put VRF equipment on the roof. The second option is to put VRF equipment in the garage. And the third is to offer a VRF green building solution. So as I stated earlier, the other costs for rooftop units would be the screening. So for the rooftop design for this building, two 105-ton rooftops, 210 tons of cooling will require 350 lineal feet of rooftop screening. Additionally, on each floor, have to provide a duct loop from those units. The duct loop will require the plenum space to be approximately 30 inches high, not only to allow for the ductwork, but to allow for the other systems such as fire protection that would go in the ceiling plenum space. For the tenant build-out portion of the project, we based it on 26 VAV boxes and all their distribution ductwork, diffusers, and controls, and we chose 26 boxes just at 1,000 square feet per zone as a base. So let's get into the costing here. So for traditional rooftop VAV, you can see the landlord work, $713,000. Again, it's a 78,000 square foot building. We're going to keep talking about per square foot numbers. So that's $959 a square foot. Tenant improvement portion, $622 a square foot. Mechanical total for this project, $1,581 a square foot. Now let's talk about those other costs. So we've got 350 lineal feet of screening at $1.09 a square foot. Power for the rooftop units, 0.58 per square foot, and structural steel for the rooftops, 0.26 per square foot. Has an other total of almost $2 a square foot that needs to be added to the landlord's portion of the work. So once we do that, the mechanical portion of $959 plus all the other costs end up to an equivalent landlord cost of $1,152 a square foot. Tenant improvement stays the same at $622 from the previous slide for a total of $1,774 per square foot. Graphically, we're going to represent that like this. So as we move further forward with the other pricing options for VRF, landlord work is blue, tenant improvement work is red, total cost on the top of the project of $1,774 per square foot. So our first option for VRF equipment is to put our hyperheat equipment on the roof. Again, this is based in Milwaukee, so we will require the hyperheat equipment to provide heating at the low ambient conditions. 24 8-ton hyperheat units equal 192 tons of cooling. You'll need a DOAS unit. 6,000 CFM is the nominal 24 tons of cooling. That is 216 tons. We tried to equate to the rooftop portion of the bid, which was 210. Because of the module sizing of the VRF, we're slightly over. I wanted to be conservative on the VRF portion of the pricing, so we have a few extra tons of cooling in the VRF solution, just based on module size. However, this slide is showing that you'll only need 160 lineal feet of screening instead of the 350 required for the rooftop units. For the VRF design, we'll put 4 branch controllers on each floor and include all the refrigerant piping from those branch controllers up to the outdoor units on the roof. And then the blue is the outside air duct from the DOAS unit, just out into the ceiling plenum space for the return. Now this VRF system only requires ventilation of outdoor air, so a much smaller duct can be provided so the plenum size can be reduced. Now you'll only need an 18-inch plenum instead of a 30-inch plenum as per the rooftop design, and that equates to some owner savings. The exterior wall cost is approximately $40 a square foot. If you do the math with the exterior dimensions, 175 by 150, reducing at 12 inches per floor over 3 floors, provides a reduced plenum savings of $78,000, and that will show up in the other costs on this next screen. Indoor units, we tried to maintain an apples-to-apples comparison to VAV boxes. So we have 26 indoor units, 1,000 square feet per zone. And from those, we would include the refrigerant piping to the branch controllers, as well as the distribution ductwork. So again, similar to what we did in the rooftop design, we now have a VRF of 1038 per square foot for landlord and 776 for tenant improvement for a total of 1881. We again take these other costs, which is a reduced amount for screening, Electrical is actually slightly higher. It takes a little more to run the power wiring to 24 VRF units than it does to 2 rooftop units. Structural steel is a little bit less. The VRF equipment weighs less than the rooftop units, so we save some money there. And then we've got the reduced plenum savings of $1 a square foot. So the other total that gets moved to the landlord work for the VRF solution is only 67 cents a square foot. So again, add that to the landlord portion of the mechanical system of 1038, becomes 1105 for the landlord, and 776 stays the same for the tenant improvement. Building on our graphics from before, you can see that the VRF solution is slightly less expensive to the landlord, a little bit more expensive on the tenant improvement side. So that was for VRF equipment on the roof. Because this building has a parking garage in it, a viable solution is to move the VRF outdoor units into the parking garage. This slide actually shows a picture of a system done similarly, where we've got the outdoor units mounted along the outside wall, ductwork on top of them, and the ductwork is either recirculating the air back into the garage or exhausting the air out of the garage, depending on the season. To do that, have the same number of units, but we have to add 3 million BTUs of unit heaters for supplemental heat. So we show the units on both sides and then the unit heaters there. The important thing with this design is by moving the outdoor units into the parking garage, we do not require the hyperheat units for the low ambient performance, so we save money on that portion of the project. Similar to the rooftop design, the only thing that we would have on this solution on the roof is the 6,000 CFM DOAS unit, and most likely would not even require rooftop screening because it's dead center in the middle of the building and very small. Same as our first VRF design, 18-inch plenum height. We still have the 4 branch controllers, same refrigerant piping from the branch controllers up to the outdoor units, and the same outdoor air duct stubs on all 3 floors. Indoor units, exactly the same way as the level 1 VRF solution. Cost, $1066 for the mechanical portion of the bid. The VRF for the electrical is $65,000 or 83 cents a square foot. Structural steel now is only required for the DOAS unit, so it's an even smaller amount, and we still have that building height savings of $1 a square foot. So the landlord work for this option is only $1055 a square foot, tenant improvement being the same at $776 for a total of $1831. And again, if we go graphically to show it compared to the others, slightly less expensive on the landlord side, same cost on the tenant improvement side. So that's a VRF equipment on the roof versus VRF equipment in the parking garage. And then the final option that we're going to show is a green building solution. So this would be, as we built our VRF options here, we took a good, better, best scenario. VRF green solution would be the best scenario in design. Questions to ask any developer in looking at a green building would be, are there any green office buildings in your market? If there are, do they get a premium lease rate? And we will circle back around to that a little bit later on in the presentation. Is that lease rate premium equal or greater than the energy savings? Is it easier to find tenants for a green building? Where do you think demand for them will be greater? Do you think demand for them will be greater in 5 years? Finally, what does it take to call a building green anyway? So first, we would add a solar array. And I would throw $25,000 at the solar array. That's not enough to cover all the costs, but additional costs above that can typically be covered by companies willing to pay the initial capital expenditure in exchange for their reaping the electrical savings. And because we made that assumption, we did not include any energy savings for the solar array in the calculations that will follow. Secondly, we would add low E glass. Low E glass will reduce the cooling load by 16 tons. Also, it does add some cost on there. Rule of thumb for glass is $45 per square foot with a 10% add for low E glass. We based our pricing of the glass on 3 bands of 5-foot tall windows around the entire perimeter at that $5 per square foot premium over standard windows. Also in this solution, energy allocation rather than blindly lumping energy cost into the CAM rates is a given, and our city multi-control network provides that option as part of the original package. So now we've got, similar to what we had in our first option with equipment on the roof, this would be hyperheat VRF equipment. You only need 176 tons because of the reduction in cooling load, have the same DOAS unit as the other options, and we have the same rooftop screening as our first VRF option. So a lot of commonality in building these quotes. On each floor, we'll have the same branch controllers, refrigerant piping from the branch controllers up to the outdoor units on the roof, and the outside air duct stubs on each floor. Indoor would be exactly the same, 26 units at 1,000 square foot per zone. You'll notice on this slide, slightly different layout for the ventilation ductwork. Instead of just dumping it into the return air plenum to be mixed with the return of the indoor units, we are actually hard ducting it to each of the return ducts of every indoor unit. This adds a little bit of distribution ductwork to the quote. We didn't include this in the other designs, just trying to get to a low first cost option. This being a premium option design, this ductwork adds about 50 cents a square foot to the cost of the job. So again, building it the same way we built the others. We've got the landlord work is $962 a square foot, lower because of less tonnage. We've got the same rooftop screening from before for the VRF equipment. We've got the same electrical for the VRF, structural steel for the VRF. We've got the plenum height savings, but we do have to add the cost of the low E glass and the solar. So the low E glass is a $50,000 add based on the parameters we just went over in the previous slide, and then we threw in $25,000 for the solar array, so that adds 96 cents a square foot to the cost. Makes the effective landlord price $11.18 per square foot. Tenant improvement again stays the same. So the total for this design is $18.94 a square foot. So again, graphically representing that, you can see that landlord work is $11.18 compared to slightly lower options in the other VRF designs. So final thoughts on this. Energy savings are most assuredly present in any VRF solution. So any energy modeling expert will agree that simply using VRF brings 30% savings compared to VAV rooftop design for an office space. Add another 5% savings due to the reduced window and ventilation loads for the green building. And if we agree that $1.30 per year per square foot is the norm for total energy costs in conventional offices like this, and we agree that HVAC comprises 50% of that total, then a 30% savings to HVAC energy use means energy costs will be reduced by a minimum of 20 cents per square foot per year compared to the rooftop baseline design. This will provide a 6-year simple payback for this option. But what we're forgetting on the green building is how about a premium on the lease rate due to the building being green? Depending on how conservative or progressive the locale is, green can realistically carry a 3.5% to 7% premium. Some claim higher, but after negotiations, the premium is usually in this range. National average lease rate for Class A office space is $19 to $19.50 a square foot. So if you can get that increase in lease premium, you're going to add 65 cents to $1.30 per square foot in income. So we can expect making this building green to have that positive impact. If we round it off to $1 per square foot, that's equal to a 5% increase in annual cash flow for the life of the building. This alone reduces a simple payback for this upgrade to less than 2 years, considering savings in energy and increase in rental income alone. So the other thing to remember is must always factor in that other cost when evaluating the options. It has significant impact. So if we look at all the options we had before with the other costs broke out, you can see that any VRF option we have presented is a lower cost to the landlord than the rooftop design. Now, if you just look at the mechanical portion of the bid, that is not the case. The mechanical portion of the rooftop at $9.59 a square foot is the lowest cost. However, you have to add all those other costs in there. Effectively, the VRF solutions are a lower cost. Bottom line is, no matter how you slice it and dice it, VRF solutions are the lowest cost to a developer. One thing we also haven't talked about here is what we've called a deferred cost, which is another option for a developer to save even more money. We were talking in the previous slide, 1105, 1055, and 1118. By deferring the cost, and the owner can save even more money. And the way that we're thinking about doing the deferred cost here is that most people look at an apples to apples comparison of VRF against VAV rooftops, and that's matching tonnage for tonnage. So for this example, you have 210 tons of rooftop, all in the shell cost, and 210 tons, or 216 in our case, of VRF. This really isn't the most cost-effective design or the most aggressive way to minimize the developer's cost. We consider how we satisfy a first cost-driven customer along with some very aggressive ways to minimize his costs by shifting them to the TI portion of the project. And we accomplish this by providing only 128 tons of outdoor units connected to the indoor units. This 128 tons of cooling would temper the building to maintain the building at 60 degrees in the winter and 80 degrees in the summer until such time as tenant leases are secured. If anyone is interested in further discussion on that, we'd be happy to talk to you about that at a later date. So with that, bottom line is developers can now install premium HVAC systems of VRF design at a lower first cost than traditional HVAC systems. So with that, turn it over to questions.
Rich, thank you very much. That was a fantastic overview. I'll let you get a breath here. We've got 3 questions for you related to comments within your presentation, things that I'm a little curious about. One of the things that you mentioned was lower CAM rates or utility costs. Now, I think we'd all agree that lower is better, and lower utility costs and CAM rates are good, but they're not really a direct benefit for the landlord of a building. How can we place a tangible benefit on lower rates for landlords?
I think firstly, if you look at lower CAM rates, they ultimately make that landlord's building more competitive in the marketplace. Another option would be if you use a market standard CAM rate, you could potentially have another profit center by effectively managing your utility and energy costs with our VRF system.
That's a great point about making the building more competitive in the market. I know that's a competitive advantage, or can be, for some landlords or building owners to really get people into their buildings. So thank you for that, Rich. The second question is around paybacks. The simple paybacks and simple payback calculations seem like they can get a little bit long when it comes to VRF systems. So how do we address or answer that question of longer, simple paybacks on the system?
Well, I think the first thing you have to say is simple paybacks are longer now just based on the lower cost of energy. As rates continue to climb, simple paybacks will come down. I think what we need to tout is the life cycle cost analysis of VRF, as the systems have an effective life almost twice as long as packaged rooftop units. When you do a life cycle cost analysis, it's a no-brainer to go with a VRF solution.
And I think that also, by doing that, lends credibility even more so to the charts that you were showing around VRF being that lowest first cost in a lot of cases. The life cycle costs will go along with that and really be a benefit to the owner over the life cycle of the system. The last question I had for you really is around deferring costs. So when we defer costs, and it's an interesting topic that you brought up and something that I'm definitely interested in learning more about, when we defer the cost for the HVAC equipment from the landlord, in this case to the TI build-out, how does that work if some spaces are already finished before this equipment is required?
Well, the way that we built the budgets on that was just to make sure that we wouldn't have a problem with that. So what we did is all the work located within other spaces, or potentially in other spaces, will be completed as part of the landlord's work. So the refrigeration piping from the branch circuit controllers to the outdoor units will be routed all the way through the building, out the roof, and then if you go with a deferred solution where you're not putting the outdoor units on yet, we would simply cap them off above the roof. So they would be pressure tested and tight so that you wouldn't have to go in, for example, if a tenant was on the third floor and a new tenant is moving in on the first floor, the piping would already be installed in between the first floor and the roof. So the only work would be involved would be in the tenant space being built out or up on the roof out of other tenants' spaces.
That seems like a huge benefit to the landlord as well as the other tenants that might already be in the space. Definitely something that is a positive for a building owner or a landlord. Rich, thank you. These are really my only three big questions after listening to the presentation. There was a lot of good information in there, a lot of facts and figures, and really shows the amount of work that you put into this. So I appreciate you taking your time to tell this story today. If those of you that are watching today's webinar have any questions, feel free to reach out to Rich or to myself. We'll make sure that we get you connected with the right folks to answer and address those. And just remember that this simulation is based off of a hypothetical building in Wisconsin, and the same simulation can be run on buildings across the country, depending on the specific parameters of the building, and you can do the math behind it to come out with some dollar per square foot costs and run another simple calculation. So Rich, thank you very much. We appreciate your time. To those of you listening, have a great rest of your day.